Two variables x, y are negatively associated. Does this mean the above average values of x will always be associated with the below average values of y? Now, the key here is the word always. So just as we mentioned earlier on, that in statistics, whenever you see a word like this, which says 100% or always or certain, alarm bells should be ringing, because statistics is generally about approximations and probabilities, and we rarely are completely sure about something. So in regression also, just because there's negative correlation doesn't mean that there will always be this kind of relationship, but in general there will be this kind of relationship. So basically we have to look for the same idea as expressed here, but with a milder word than always. So the same idea is okay, now because association does not mean that every point fits the trend, the negative association only means the above average values of x are generally associated with the below. So instead of always, we can say that that's generally the case. Determine whether scatter diagram indicates that a linear relation may exist. If the relation is linear, determine whether indicates positive or negative association. So it seems that yes, there is a positive linear relation because the points as a group seem to rise. And so do the variables have a linear relationship? Okay, C seems to be the idea, have a linear relationship because they lie mainly on a straight line. And then they ask whether it's positive or negative. So we already figured out that it should be positive. And now we mentioned the correlation coefficient some time ago. Now it's time to actually start calculating. So here we have our data and we have to find the linear correlation coefficient. So one way to do it on StatCrunch is that you open it in StatCrunch. And you do stat summary stats. Okay, no, not summary stats, but stat. Okay, you can do stats, summary stats, and correlation. Okay, that's one way to do it. Another way to do, which I was looking for over here, is stats and regression and simple linear. So you can do both ways. So the first variable comes in the first box and the second variable comes in the second box. And after that, you just hit compute. So you look for R, and R is over here, 0.1582. Find the critical values of R from the table showing the critical values for the Pearson correlation coefficient. So the critical values table is over here. If you look at the table, the first column, n, means how many data points do you have. So here I see 1, 2, 3, 4, 5, 6, 7, 8 data points. So I will look corresponding to n equals 8, and they say look for alpha equals 0.05. So n equals 8 and alpha equals 0.05 gives me 0.707. Now, alpha is the allowable error. You remember that you had two alphas there, 0.01 and 0.05. 0.05 will be used if you're okay with being 95% accurate, means having an error of 5%. But if you want to be more accurate and you want to be your error to be 1% or less, then you go for the 0.01. And the critical values are basically the touchstone which help us determine whether there is enough correlation or not. So in our problem, the correlation coefficient was 0.158. Now, in this situation, the critical value needs to be plus minus 0.707, which means if our R is positive, we'll be looking at the plus value, and if our R is negative, we'll be looking at the negative value here. So this value, which we got, is less than the critical value. So the critical value is the threshold. So you need to be at least that much in order to have sufficient correlation. So we have a correlation coefficient way less than the critical value. So for practical purposes, we can say that there is no correlation. I mean, there is some correlation because no correlation is zero, but if you are less than the critical value, then the correlation is so insignificant that you can also say in common language that there is no correlation. So is there sufficient evidence to conclude that there is linear correlation? No, because the absolute value of the correlation coefficient, oh, well, the absolute, there should be no, okay, all right, this D was hiding, so it's not, absolute value of the correlation coefficient is not greater than, it's this one, because the absolute value of the correlation coefficient is less than the positive critical value, right? This one was less than the critical value.